In this video, we'll be covering starting maintenance tool for the first time. So the first time you boot up maintenance tool, this first option that's going to display has to do with display scaling. So if you're on a high resolution display like a Microsoft Surface or similar, something much higher than 1080p, you want to enable auto scaling, and then you'll have to restart maintenance tool. In this case, I'm going to leave it disabled, which more often than not is going to be the case. And I'm going to check this box so the window is not displayed when starting maintenance tool, so it doesn't pop up each time I start maintenance tool over again. The next is going to be our units of measurement. So right now it's in metric, so we need to change it to freedom units of degrees Fahrenheit and PSI. The additional one we need to change is this capacity. Capacity code reads out a number that doesn't necessarily make sense. UL model number is the one we want because then if you have a 12, it's a 1-ton unit. 24 is a 2-ton unit. Then we're also going to display this window is not displayed when starting maintenance tool. I'll press OK. Now we're going to pick and choose our MN converter type. When you first start it up, it will probably be on the MNF, which is not the case. We're going to pick the PAC US CMS-MN-1. That's the current red box and what you most likely have. And COM port, the one that says USB on there. Now, if you don't have anything pop up here, it means that you started maintenance tool without your MNet tool plugged in. So we'll need to do that. So all we're going to be covering now is being able to connect and start auto searching the system. So with MN converter selected, we go ahead and hit select. Now it's going to roll through the menu. It can take a little bit of time. And the first time you start up maintenance tool, it'll typically take longer. Now we're going to start our search. So I always leave it on detail because detail gives me a whole bunch of extra information that the others don't. It takes a couple seconds longer per unit than standard, but this is already a slow process, so waiting a little bit of extra time and getting information like the power outage state of a unit, whether it's got line voltage or not, and what its last error code was, is greatly worth it in my mind. So I'm going to hit auto for this, and it will start searching. The first thing it sees, because I have a central controller out here, is it's going to see the AE200. So that's that TR. And now it's searching for individual fan coils. Now that our address searching has been completed, we're going to go ahead and go into the monitoring view. And I'm going to be looking at both of these systems today because I'm taking test run data in order to see how the system looks after it's been started up for, I think it's been over a year. So they want me to do a check on this. So we have this. We have our two different OCs here. I have two systems. When you hover over the OC, you can see on this connecting information down here what we have going on. And because we did a detail search, we can also see what the last error code that unit saw was. So we'd have to go into the error history to see when it saw it, what the actual specific unit was, but it's not flashing red at us. It's green, it's running, so it's in a normal condition. So going into monitor, we click on monitor. This tab will now be highlighted. I'm going to click on this OC and this OC. One thing you don't want to do is you don't want to click on all of the different units, because while it will pull them in, it doesn't pull them in an order that makes as much sense as if you were to just click on the OCs. So clicking on the OCs by themselves not only makes it is less button pushes, but makes it the result better. So now we're going to go ahead and let's repeat this. We did monitor, so monitor is highlighted. I'm going to click on OC, OC, and then hit confirm. Now we're going to monitor, and this will take a little while to load. Our monitor screens finally come up, so I'm going to change the size around in order to be able to see things better. Now, as you can probably tell, and especially if you're watching from a phone screen, this is extremely hard to read. These are it's very small text here. So what we're going to do is up here there's a little A with an arrow. If I hover over it, it says font size. Here I can select the font size that I want. In this case, I want a large font size. Now, when I talked about how we only want to do the OCs, here's why. So this is that first OC, address 51. Address 52 is my main BC, and I have address 62 as my sub BC. Down below here, I have all the indoor units that are on that system. Here we have outdoor 69, BC 70, and the indoor units that are connected to that system. if I were to instead have clicked everything, what I would see is this OC, and in order, then this OC, then the BCs, then the sub BCs, and every single indoor unit would be in one window like this, with no easy way to differentiate which system they're on. So up here in the upper right, we have our time. So this is minute 2 of 2. This will continue to scroll through, taking logs once per minute. And we can just keep going and read some logs. As far as these little highlight conditions I have, where these 41s on the expansion valve are, the expansion valves are highlighted yellow at 41 pulses, which is their closed position. TH2 is lit up blue because the pipe is cold, and so on and so forth. I will show you how to set up those in a future video. But for now, here's getting into the monitoring screen and being able to take some logs. Now we're going to put our system into test run. I'm going to do test run cool. So right now my outdoor units are stopped. So I'm going to go to drive operation, indoor coil. So that's IC is for the indoor coil. So there are 3 options available on this screen. Set individual, where you can set an individual fan coil unit using the buttons to change its address and move around. Rarely will we use this, except if we want to override the LEV position. Set selected addresses, where you can select which fan coils you want to use. This is useful if you're doing a single system. So like that first system there is 18 and below. So I could select all of these and only command my first system, or select all of them and command both systems. The other option is to do set all, which I'll only do on a site with a large amount of fan coils, because when you end up doing the whole site, when you do it via set all and you hit transmit, it will search all of these other units for anything else there and then ask you if you want to transmit. And since I've already got these highlighted, I'm going to be doing set selected addresses. So what I'll be doing is I will be putting it into test run. And this box got checked. Every once in a while, when you click on something, it may not check the box. So I'm clicking here. So in that case, you would need to go over and make sure this box is checked for anything you want to send. And I'm going to put it into cooling mode. What I'm not going to do is I'm not going to change my temperature set point. I already have temperature set points in these units, and it's an existing space, and they may have different set points for different units. As long as this box is not checked, it will not send temperature set points. Same with the fan speed. If I don't have this box checked, it will not send these to the fan coils. So all I'm sending is test run and cool, and then once I'm done, I can go back to operation auto and leave things where they had been at. So now I'm going to go ahead and hit transmit. It's going to ask me if I want to batch operate these units 1 through 29, which is what I highlighted, and yes, I do. So I'm going to hit yes, and then it's going to go through and command these. I will pause and return once these have all finished commanding. All the units have finished commanding. It's telling me setting complete. I'm going to press OK, and then I'm going to exit out of this screen. You want to make sure that that screen gets exited out of anytime you're done commanding, because otherwise maintenance tool will not continue pulling data while that screen is open. I've actually lost an entire hour worth of data logs because I was jumping around between multiple computers. I didn't exit that screen, and I didn't have any data logs to take or to save. So that's a little bit annoying. So right now we're waiting. Okay, everything's gone into test cooling, as you can see. So our mode is we're now in test mode. We're in cooling. We still have some units, as you can see with these 41s, that haven't opened their valves yet. But once again, maintenance tool only grabs everything once a minute. So on here, it hasn't even grabbed anything yet. So I will return. Well, I'm going to pause again and come back in a few more minutes. We're at minute 47 right now. Once everything is actually getting to temperature, and I will demonstrate how to do a port verification. Now that all my fan coils are nice and cold on the liquid pipe temperatures, we're going to start our port verification process. So what I'm going to do from here is I will do drive operation BC, and that's for my main BC. And this is where we're going to start at. So I always start at branch number 1. So what I'm going to do here is I'm going to click this guy. So I'm going to turn off SV A and C, which are the port solenoid valves used for cooling. And I'm going to hit this fix to fix it in place. When it's C, it's for cancel. So that's going to override us. I'm going to hit transmit. I'm going to hit monitor to see that the command took. And it did. So now I'm going to close out of here. And we will wait until one of these fan coils loses refrigerant. Okay, we're a few minutes in, and we have lost refrigerant flow on this fan coil unit. It happens to be branch number 1, and we were checking branch number 1, so that's great. Now, this one did take a little while to change, so when we go into this next port, drive operation BC, I'm going to show you a trick that I use when we're in a test run cool and trying to do a port verification that makes things run a little bit quicker. So first I'm going to go ahead and turn off A and C. I'm also going to turn solenoid B, which is my heating solenoid, on. I'm only going to leave it on for just a second. And then I'm going to hit this C to clear to remove that. I'm going to hit transmit. I'm going to pop right back over to here. I'm going to hit transmit again. So I turned this back off, and now I'm going to hit monitor. As you can see, since this override is gone, these two valves open back up on their own. So now we're going to close out, and we're going to wait and see which port opens. Okay, so this was only 1 minute later after this, and we're already seeing a large jump in temperature up here. So I can say, and TH3 really went up. So 52 to 72, because it got that little bit of high side going in there. So we've lost refrigerant on that one. So branch 2 was what I tested. Branch 2 is there. Excellent. So now we're going to go ahead and test branch 3. So drive operation BC once again. And maintenance tool is a test of patience. It does take a while to load. So I'm going to go ahead and do the same thing I did last time. I'm going to hit transmit here. And then I'm going to close this valve back down. Then hit transmit. And I'm going to hit monitor. Yep, these open back up, so I know things were good. Now I'm going to hit close. So we're going to watch for which device loses refrigerant when port 3 closes. Also, before we run into an issue, I do want to point out, you see how these numbers up here now are red, 64 of 64? This will turn into 64 of 65. And it will then turn to 64 of 66. It will stay on this page unless we go ahead and we press this online again. Now those numbers turn black, and the frame will auto-update once it gets there. Okay, as we can see, this device lost refrigerant. But notice this. I've got 2 devices on port 3. Well, you can actually have multiple fan coils on one port, but what's going on here is the sub-branch controller. When you have a sub-branch controller, the important thing to note is what is its address, because the sub-BC needs to be addressed 50 higher than the lowest indoor unit connected to that sub-BC. So all indoor units that are not on the main BC have to be addressed higher than those on the main. But we can take the corollary of that. So I've got this 62, and I subtract 50 from it. That leaves us with 12. So I know that fan coil address 12 and up are on the sub-BC. So this is port 3 on the sub-BC, and this one's port 3 on the main BC. If for whatever reason I saw this guy change, well, that would mean that I'm piped up wrong, or my MNET addresses are wrong, or something like that. But in this case, we're good. In fact, I know that every one of these is good because I did the startup on this system. year or so ago. Oh, and as if you noticed, I've been highlighting the model numbers. I do this to keep track of which units I've successfully verified the port assignments for. Now we're going to go ahead, and so I will just keep doing that, and then I'll typically highlight here and start recording a log of what's wrong and what it needs to change to afterwards. So I'm going to rinse and repeat, and actually I'm going to go ahead and clear out the overrides on the main branch controller, and we're going to stop this one, and then I'm going to go ahead and show you how you get to a different BC. So I'm only worried about this one system at the moment, and shortly I'll get into how you can get to the branch controller on a second system. But so we're going to go to the sub BC. So I'm going to do drive operation BS for sub BC. So then I'm going to go ahead and close off port 1. And once again, I'm activating that SVB for just a second in order to cause the solenoid to switch better. And we're going to be monitoring to see which unit loses refrigerant now, because we're going to be looking at port 1 on the sub BC, and we're no longer looking at port 3 on the main BC. We're now looking at, so we were looking at number 1 and on the sub BC, and we see that this device lost refrigerant, which is port 1, and I know that it's on the sub BC, or should be, because 62 minus 50 is 12, and 12 and up, this happens to be 18, are there. So let's go ahead and clear out of the, let's go ahead and clear our override on the sub BC, because this would just be rinse and repeat to make our way through until we finished all the ports. And now I'm going to show you getting to, since I'm monitoring multiple systems right now, getting to this next one. So this BC is address 70. So I'll go to drive operation. I don't have another BC and BS and whatnot. So I've got this BC, and what we'll do is we'll get the drive operation going, and I'll hit this address change box. So I'm going to go to address 70. So as you can see, right now this attribute is blank. But if I scroll down here, we'll see that the attribute is BC. So I'm going to press OK on this. And now I have the port, I have BC address 70. Do my same thing. And there we go. Now we're going to be checking on which fan coil loses refrigerant and figure out which one is our port 1. All right, as we can see, we lost refrigerant on address 21, branch number 1, and we closed branch number 1, so that one is correct. Now we would continue on, if we were doing a full port verification, we would continue on through this whole process in order to, make sure every port was correct. My recommendation is that when you first start off doing port verifications, do not do multiple systems at once. When you go into your monitor, hit monitor, OC, pick just one system, and go ahead and verify the ports on that. And do them separately. It will save you a lot of headache trying to keep track of a lot of things going on at once. Now, one thing I do want to note, if any of these ports had been incorrect, it wouldn't change the speed at which the port verification was going. So let's say, for example, on here, instead of when I closed off 1 on the sub BC, instead of this one losing refrigerant right here, let's say that this device right here lost refrigerant. So this guy. Well, what that would mean is that, okay, I closed port 1. This is set to 6, but it's physically connected to port number 1 on the sub BC. And I know that because, well, I just killed refrigerant on port number 1. So what this would mean is that after I finish my port verification, because you want to go through and do all of these, you would go ahead and take this and change this on fan coil address 15. You're going to change dial 6 to dial 1 based on what port it's actually on. And that is going to conclude this video on how to do a port verify, how to start up maintenance tool, because that's what we went ahead. We started up maintenance tool. We went ahead and set our initial settings that we needed to, screen display settings and units of measurement. We've gone through and gone into monitor mode, thrown everything into test run, and have gone through the basics of a port verification. Please leave comments in the video if you would like a more in-depth video on port verification, including examples of ports being wrong. And I've also been considering building a PDF file that is just a nice, basically startup form for doing a port verification to help keep things in line. So please let me know in the comments if you would be interested in that, and I will work on it. Thanks for watching.